we have finished the first 3 units so far from the syllabus, and this is your fourth unit. So this is the revised Python syllabus, which I was discussing in the previous classes. So in the fourth unit, so we have the concept of inheritance, and then the second part of the fourth unit is modules. So modules part is over. We already have discussed these modules in the previous sessions. So if I discuss the concepts of inheritance, then your fourth unit will be over. So what is there in inheritance? In inheritance, we have the introduction to inheritance, like what is inheritance and types of inheritance and all that. And we'll be seeing examples for each and every type of inheritance. And then we'll see what is method overriding. And then we'll see abstract classes and interfaces. So with that, we'll be finishing the fourth unit and we'll be moving to the fifth unit, which is exception handling. Okay, fine. So let us get started. Okay, so this is inheritance. So inheritance is the same meaning like what we talk in general. So what is inheritance in general? Like we being children acquire the property of the parents, right? So whatever the parents have acquired, so the parents will give it to the children. Children automatically becomes the higher of the property that the parents have earned. So the same concept, okay? So that's why we are saying that it is inheritance. So how do we apply the same kind of analogy to the programming subjects is that, say for example, I'm having a class A, okay, and class A is having certain things in it, okay. What are all the things that a class can have? The class can have the variables, right? So it can be a class variable or it can be an instance variable. So a class can contain variables. Apart from the variables, so this is the data members of the class. Variables are considered to be the data of the class, and apart from the data of the class, a class can contain methods, right? So it can be different types of methods. It can be like the instance methods, or it can be the class methods, or it can be the static methods, or whatever, private methods, anything. Okay, so a class will be having these kind of things in it. What do a class contains? A class contains the data members and the member functions. Okay, so these member functions are called as methods. So a class will be comprising of this ones, and this variables and the data and the methods that we are talking about are independent of this class. Now say I'm having another class B, and this B class is independent of itself. So B class will be having its own variables, data members, and its own functions. Now say for example, this class B wants the variables of this class A. Okay, so say that this class B wants the variables or it wants the functions. Functions means that the methods that class A is having. So B class wants to access the variables, or it want to get the variables and the methods of the class A. So it is not possible to actually for B to acquire the properties of A unless and until they are bounded in inheritance. Okay, so that is the concept over here. So what is the definition of inheritance? The definition of inheritance is that the technique, it's a programming technique of creating new classes from existing classes. Okay, so the properties acquired from the superclass. Okay, the B now it wants the properties of A. So B will become the subclass. So we call B to be the subclass, and we will call A to be the superclass because B wants the properties from A. Okay, so it is like parent and child relationship. Okay, so parent is nothing but A. A is considered to be the parent and B is considered to be the child. What all the parent is having? Okay, so what are all the properties that the parent is having? What are all the properties here in the class? The variables and the methods that the A is having will be inherited by B, meaning that B can use the methods and variables that are defined in class A. So A is considered to be the parent class. You can also use these words. Okay, so A is considered to be the parent class and B is considered to be the child class. Okay, so when I say A is parent and B is child, meaning that there is a relationship between these two classes. Now remember that in the general analogy, you can acquire the properties that your father have earned. Okay, say he have purchased a land, or he has constructed a house, or whatever it is. Being the child, you can take the properties. You become the heiress of the properties that your father have earned or your mother have earned. Okay, so parents, any of the parents. So all the properties that the parents are having, the child automatically becomes the hire of that property. But the parent, whatever you earn, like for example, the child, whatever the property that the child is having, the parent is not eligible to take it. Only your child is eligible to take it. Okay, so this is the concept of inheritance. And whatever, for example, there are properties for B class. Okay, so B class is having its own variables. Here the properties of B means that the methods. Okay, so the methods that I'm talking about. Okay, so the properties of B, whatever are the properties of B, the say it's a data member or the methods or whatever that B class is having. A cannot access the properties of the B class, but B can access all the properties of the A class. But if there are in inheritance, B can access all the properties of the A class, but A cannot access the properties of the B class. Okay, A is considered to be the names that you can give to A is like A is considered to be the parent class. You can also say that it is a super class. Okay, or else you can also say that it is a base class. Okay, so these words are synonymical, so you can use them interchangeably. So you can say A to be a parent class. You can also say A to be A to be a base class, or else you can also say that A is a super class. Now, what are the names that you can give to the B class? Okay, so B is the derived class, meaning that from the A class it is derived. So B is the derived class. It is the subclass, right? So A is the superclass, so B becomes the subclass. Or else you can also say that B is the child class. So these are the words like you will be using. And so what is the advantage that you get with inheritance? The advantage that you get with inheritance is reusability. Now, what happened, how it is achieved? Say, for example, A is having a method which is called as add. Okay, so if it is a child class of class A, it can acquire the property, it can access this method of A. Rather than writing the code for add again in B class, you can use this method that is there in the parent class. So, reusability of the existing classes through the concept of inheritance. Now, another point is that when you have this inheritance, so B is acquiring the properties of A, right? You generally give the symbol like this. Okay, put the arrow mark towards the base class. So I'm having B. If B is inheriting the properties of A, you write it like this. Okay, so you are saying A and B, and in between A and B, you will be putting an arrow mark, and the arrow mark should be pointing to the base class, meaning that B is the subclass and A is the superclass. Now here, if they are in inheritance, it does not mean that A is not independent. Okay, so you can access A as it is. Okay, so B is an independent class, but the point is that you can create objects for the A class, and you can directly access the properties at the data and the methods that are there in the A class also, even if it is in inheritance. Okay, so it is an independent class. You can create object of A class, access the methods with the object of A class, and all that you can do. Okay, but since B is acquiring the properties of A class, from the B class you can access the methods of A class also. Okay, through the object of the B class, you can access the methods and the data of the A class. Again, here another important point is that you cannot access the private members of the A class. Okay, other than the private members of the A class, everything is derived into the B class. Okay, private members are not inherited. So this is again a very important point. The private members of class A, even if it is in inheritance, is not acquired by the class B. Okay, so the reusability is that create new classes from pre-written or tested classes. So if there is a class A, you can derive it. Okay, so from it you can derive another class. So that old or existing classes is called the super class or the base class or the parent class. Okay, and the new class is called as the subclass or the derived class. Okay, and this is again another important MCQ. So wherein in Python, every class is inherited from the base class object. Okay, so there is an class which is called as an object class, and every class is an inherited class from the object class. Okay, so even if you don't give object class in the syntax, but internally it is inherited from the base class. And what is the name of the class? This is inbuilt one. Okay, so which is object class. Now, fine. Let us just look into this particular diagram. So here you can say that this is inheritance. Okay, so which we are trying to show it in terms of hierarchy. So a person class is there. Okay, so here say that there is a class which is called as person. Okay, and what are the properties that the person class will be having? The person class will be having a name, age, and then so those are some common things a person will be having. Okay, so a person will be having name, age, and so on. So these are the data that a person will be having. Now you want to create a doctor class. Okay, say you want to create a doctor class. Doctor is a person in turn, right? So what you can do is you can actually make this doctor a subclass and person as the superclass. You can derive doctor class from the person class. Okay, and what is the relationship between the superclass and subclass, which is a relationship? This is again an interview question. Okay, so what is the relationship between the superclass and the subclass? It is an is a relationship. Okay, now aggregation is there, so that is has a relationship. So these are all the association between the classes, and here the inheritance means that it is a relationship. These are all very important interview questions. So person is a doctor is a person, right? So if you read it in this way, you will be able to understand it much better. So doctor is a person, patient is also a person. So you can say that the patient class is derived from the person class. Okay, and from the doctor class you can also have a dentist class. So dentist class is derived from the doctor class, and the doctor class is derived from the person class. Okay, so this is a kind of multi-level inheritance. Okay, so dentist is the subclass, its superclass is doctor, and doctor's superclass is person. Okay, and surgeon is here. Surgeon's superclass is doctor and doctor is person. So if you look it from top to bottom, it is like surgeon is derived from doctor, doctor is derived from person. Okay, and dentist is derived from doctor, doctor is derived from person. So person is the generalized class, and you can see as we move down into the hierarchy, you can see next concepts. As you move down, you will be getting more specialized concepts into the classes. So person is more general, from wherein you have made it a bit special over here, making that a person, the doctor, the person is uh, a doctor over here. And in the next level, you are saying the doctor is a dentist. So again, you are mentioning it in terms of specialization. Okay, right. So this is the person is the generalized class, and you can see that the dentist is the specialized class. Okay, so the person is the generalized class, and the dentist is the specialized class. As you move down into the hierarchy, you'll be getting more specialized classes and with added concepts of itself. Now, for example, doctor class will be taking all the properties of the person class, as well as it will have, plus it will have its own methods. In the same way, the dentist class will be having the properties of the person as well as the doctor and itself. Okay, so the methods of itself. Now consider a grandparent, parent, and yourself. Okay, for example, say that you are the uh, at this particular level. Okay, so you can say that there is a grandparent, imagine yourself and your parents and you. Okay, so you are here, and your parents are having parents, so this is your grandparents. Now all the properties that your grandparents have earned, okay, so they are inherited by your parents. And what do you inherit? Both the things, right? So what your grandparents have earned plus what your parents have earned, all will be inherited by you. Okay. plus what all you earned. Okay, plus all the properties that you are earning yourself. So all this will be in you, right? All this will be acquired by you. Okay, so not only the properties that your parents have earned, and also your grandparents have earned, you yourself also will earn certain things, right? So plus yourself. So that will be this is a concept of these classes. Okay, so all the properties that the uh, first class, okay, so you can say this is multi-level inheritance. So I'm having this, all the properties that the grandparent is having will be inherited by parent class, and the parent class properties will be inherited by the child. But in reverse, it is not possible. The parent cannot access your properties, and the grandparent cannot access the parent properties. Okay, nothing is possible in reverse. Only it is possible from top. Okay, so the child can access all the properties of the parent and the grandparent, but the parents cannot access the properties of the child. Okay, right. The new classes are created first by adding data and methods from the existing classes, and then adding new specialized data or methods to it. That's what I told you. Okay, the new class, for example, this class is created by inheriting all the properties from the previous classes, as well as the specialized properties that this class will be holding. Okay, so that is the procedure of creating inheritance technique. And in this process, the base class remains unchanged. That's what I told you. Okay, so the base class remains unchanged, but you're just acquiring the properties of the base class. And the base class is independent of itself. You can create an object of the base class and access the methods and all this from the base class, and nothing will change in the base class. You're just acquiring the properties from the base class. That's it. And the relationship between the child and the superclass is that is a relationship. And inheritance follows the top down approach. Okay, so it follows the top down approach where generalized classes are created first. So we'll be creating the generalized classes first, and then we'll be deriving the classes from the base class. Okay, right. And the syntax of creating inheritance is that, so you'll be saying class, the name of the derived class. Here derived class is the name of the derived class, and here you need to put this parenthesis, and inside the parenthesis you will be writing the base class name. Okay, so you'll be writing the name of the base class name and then the body of the derived class. So this is the concept of inheritance. Now let me show you a program, a simple inheritance program wherein I'll be creating two classes, and I will show you how the syntax works and how to access the methods and data of the base class and all that. Okay, right. Base class now. So I'm saying class. So I said class, and I'm saying person. Okay, so I'm just creating a class. Okay, so what is the procedure of creating inheritance? The procedure is first you need to create the class. Okay, fine. And then inside this class, it's a regular class. You needn't worry about anything over here. So it's general class. Okay, fine. So then I'm initializing my instance variables name and age. So I set self dot name is equal to name. So as I said, a person's general qualities. Okay, so what are the general qualities of a person? So it is generally the age and name of the person. I'm not taking too many attributes over here, so it will be confusing. So you can say that I'm just having the person class is having only two attributes, which is name and age. Okay. Apart from this, I am just having a display method over here, which will display the properties of the um, person. Okay, so I'm just saying print. Inside this, I'm saying the name of the person. Okay, so I'm simply saying name, and then it is self dot name. Okay, so this is the name of the person. So, and then I'll be printing the age of the person. I'm saying the age is okay, right. So this is independently a class of itself. So you can simply create an object of this class. So I'm saying I created an object, and then I'm saying the name is Sudha, and then I am saying the age is okay, so 32 or whatever. Okay, so then I can access the display method. So I'm saying o dot display. So you can see that this is independently a class of itself. Okay, so far you know all these concepts. Okay, so I needn't tell you repeat all the concepts again because we have seen these concepts in the previous unit. Okay, so this is a simple class, and this is the init method which is will initialize, and this is the display method which is display. Okay, so this is independently a class of itself. Now let us try to create a subclass, okay, from the existing class. So I want to use the name and age from the person class. Okay, so rather than writing all this code in my class, I want to use this person class in my code. So how can I use it? So I'm creating a class which is professor. Okay, so I'm saying class professor. So professor is a person. Okay, so professor also will be having the name and age. Okay, so even a doctor will be having a name and age. Even anybody, even a student will be having a name and age. Okay, so I to create the information about the professor, I also need to print the name of the professor, right? So I'm using that concept so that instead of writing all this code inside the professor again, I'm making use of some existing class. So person class is already existing. So I just wanted to make use of this person class. Okay. So how do I make use of this person class? I'll be putting parentheses over here. Inside this parentheses, I need to write the super class name. So what is the class that I want to inherit from? So I want the class, so person, all the properties of this class person to be inherited into this professor class. So for that, I'm mentioning person over here. Okay. So I want all the qualities from the person class, meaning that all this data will be now available into this professor class. Okay. Right. And professor class is independent of itself. So you can have your init method. Okay. So and I just wanted to tell you one point here that see from the init method, because you'll be creating the object of the professor. You don't want the person, for example. You just want the professor class to, you want the data to be accessed to the object of the professor class. So inside the professor class, you are passing the name and also the age of the professor, and you want to pass the experience of the professor and the area of interest, for example, okay, of the professor or the research area of the professor. So this information I'm passing, but name and age, I need not create the name and age over here. Since I'm inheriting the properties of person inside this base, this derived class, I can actually call the init method of the person over here in the professor class. Okay, how do I call it? I can simply say person dot, okay, so the init method. So the init method is init, and then I am passing the first one is self, and then the next one is name, comma age. Okay, so the initialization of name and age will be done in the superclass. See, I'm not writing all the data over here of initialization. I'm using the method from the first person class. Okay, but I have to call it. So I'm saying person dot init, and then I'm passing to it. Okay, the rest of the things are specific to professor, so I'm initializing it in the professor class. So I'm saying self dot experience is equal to experience, and then I am saying, okay, so then I'm saying experience, and then I'm initializing the other variable. Okay, so other instance variable, which is research. So I'm saying research area. Okay, so this is the init method. And this professor class can have its own specialized methods. Okay, so I'm saying display, then I'm saying data. Okay, so the name and age is already displayed from the person class. So I can actually call this method over here. Okay, I can call this person display method over here, which will display the properties. Okay, the name and age of the professor, and then I'm writing the other two print statements to print the special attributes of the professor class. Okay, so what I want to print the experience. So wherein I'll be able to access the experience instance variable with this, and then this is research interest. Okay, research area. So this is the research area of the professor, and then I'm saying self dot r underscore area. It can be anything. Okay, valid identifier is enough. Okay, fine. So I just have finished doing the inheritance. This is only the inheritance words. Don't confuse with anything. So I'm having a base class. So what is this? This is the base class. Okay. What are the other names that you can give to the base class? The other names
Yes,
are,
class.
yeah, you can say that it is the parent class. Very good. And what is the other thing
De-
you can say? It is the,
Derived class.
it's not the derived class. It is a super class. Okay.
Super
Yes, ma'am.
class.
Okay, so it is the base class, parent class, or the super class. These are the names that you can give to the super class. So what is the super class here? So person is the base class. Okay. Now what is this professor? So the professor is that is the, I'll copy this here. Okay. So what is professor? Professor is the derived class. Okay. So it is the derived class, and it is called as the
Child class.
child class.
Class.
It is also called as the subclass. Okay,
Subclass.
is also called as a subclass. Remember? So here, what is superclass? Person is the superclass, and professor is the child class. And how do what is the syntax you are passing? You need to pass the base class name, okay, into this particular parenthesis of the subclass. Okay, so when you put this, automatically these two are connected. Okay, so whenever as soon as you have given person over here, now there is an easier relationship between the professor and person. So how you can sentence it? You can sentence it like professor is a person. Okay, so professor is a person. Okay, so that relationship is now in between the professor and person is the super class of the professor class. Okay, so individually they are they're independently they are classes. Okay, you can access the methods of the class person. So let me show you that even if it is in inheritance, you can create the object of you can create the object of the person class, and you can access it. So I'm saying o dot display, it will access it and display the information for you. Okay, so you can see this. Even if these two classes are connected over here, it doesn't mean that person class cannot be accessed individually. Okay, so this is generally a misconception that the students will be having. So I just wanted to clear it off. So person can be accessed independently. So I just showed you that it can be accessed. Okay, and now we'll create the object of the professor class. So I'm saying P is equal to so I need to write the name of the class. So the name of the class is professor, and I need to pass four arguments over here. Okay, so the first one is Sudha. So I'm saying the age is 32, and then we are saying experience, and then we are saying the research area. So you can say some data science or whatever. So I just said data science. Okay. And then now I want to access the display method. So what's the name of the object? It's p dot so then I'm saying the name of the method is display data. Okay, so I'm just calling this method. Okay, right. Now let us see the execution. Okay, fine. So you can see that the name is Sudha, age is 32, experience is 8, and the research area is data science. You can see this information printed over here. Now let me show you the process of how this is achieved. Okay, so I already told you that how these two are connected. I'll tell you from here. Okay, I have created an object of the professor class, and I have passed these things into the init method. So init method is internally automatically called. Okay, so whenever an object is created, init method is called. So for name, Sudha is passed, age 32 is passed, and experience 8 is passed, and for research area, data science is passed. Okay, now I'm saying person dot init and this is the first statement inside your init method. So I'm making a call to the superclass, okay, and I am passing these things into the superclass constructor. So what happens, this name again goes into this name, and this age goes into this age, and these two variables are initialized for this professor class, okay. And then what I did, after this initialization, the initialization of the experience and the research area happens inside the professor class, and then I'm calling this display method, okay. So I said display data. Now what happens is this person display method is called, so the superclass method is called. So name and age is printed, so you can see that name and age is printed from the display method of the superclass, okay. And then inside the display method of the subclass, so you're printing the experience and the research area. So these two statements, experience and the research area, are from the subclass. Okay, so now what I did is, in case if I want to uh, um, write, okay, so print all this information without inheritance. So what I would have done, I would have also written these two statements inside this professor, and also I would have written these two statements inside this init method. Not only this is a very simple example, but say that the methods that are there in the superclass, if you want to reuse it in your class, there is a very simple technique which is like inheritance, okay. So whenever you're working with applications, okay, so if you're working with applications, sometimes you will be having some pre-written classes or some existing classes wherein you just wanted to use those methodologies, okay. You can absolutely do that by creating inheritance between the two classes. And as soon as you created inheritance between the two classes, automatically all the properties that the superclass is having are accessed inside the child class. But you cannot access the method of the child class with the superclass. You cannot create an object of the superclass and access the methods of the child class. That is not possible. The child only can access the methods of the superclass. So this is what is called as inheritance. Is this concept clear to my class?
Yes, ma'am.
Okay, so this is the example that I already have shown you. Okay, and the concept I have shown you is nothing but single inheritance. Okay, now there are four types of inheritances, okay, that Python supports. It is not similar, it is not same with other programming languages, okay. For example, Java do not support multiple inheritance through classes, okay. That is again a very, very important question in Java, okay. But Python supports multiple inheritance. There are four types of inheritances, so you need to thoroughly go through the language to language, the types of inheritance the language supports differs only. It doesn't mean that every object-oriented programming language supports all the inheritances. So this is again a comparative question between the programming languages. The first thing is C programming do not have inheritance at all because it's a procedure language. It doesn't come into object-oriented paradigm. But the kind of programming languages that are object-oriented are like your C++, Python, and Java. All these come into the category of object-oriented OOP concepts. So in the OOP concepts, every programming language, every object-oriented programming language do not support all the inheritances. Okay, but Python supports four inheritances. The first inheritance is that it supports single inheritance, and the second is it supports multi-level inheritance, and the third one is it supports hierarchical inheritance, and the fourth type is that it supports multiple inheritance. What are the four types I told? The first type is the single inheritance. So this is an essay question, and you can expect this question in your university examinations. Okay, university exams lo you explain the types of inheritance with suitable examples and question adagachu. Because this is a very, very important and common question in every, almost every question paper. You will be seeing this question, a common question. Okay, the first one is single inheritance, and what is the second one? The second one is multi-level inheritance. Okay, multi-level. Okay, multi-level ending. Okay, so the second one is multi-level inheritance. What is the third one? The third one is hierarchical inheritance. Okay, so it is hierarchical inheritance. And the fourth one is multiple inheritance. Okay, what are the four types of inheritances? Somebody repeat.
Single inheritance, multi-level inheritance, Hierarchical inheritance,
Inheritance, okay?
Multiple inheritance.
multiple inheritance.
Inheritance. Repeat it, ma.
Single inheritance,
Ah,
Single
multi
inheritance, multi-level inheritance, hierarchy
inheritance,
inheritance, multiple inheritance.
multiple inheritance. Okay, so these are the four types of inheritance. So in the single inheritance, there will be only two classes. The example I have shown you right now is an example of the single inheritance. Okay, now I have shown you the example of person and teacher, professor and all that, right? So it is an example of a single inheritance. You will be just having a base class and a derived class. So what is the base class in the example I told you? The person is the base class that I showed you. And what is the derived class? The professor I told you is a derived class. Okay. So now just understand that the example that I have shown you is a single inheritance. Okay. Right. So I'll be having a superclass and a subclass that only one level ఉంటుందండి. So there won't be any other level. So this is called as single inheritance. Now let us look into how to print the base class details by using the basis attribute. In my previous unit, when I was discussing about the built-in functions and attributes, I have shown you one of the attribute which is the basis attribute. So what is the purpose of the basis attribute? The purpose of the basis attribute is to print the base class of a class. Okay, so herein I just have a class person, I have a class teacher, and teacher is derived from person class. Okay, now what I did is I want to know that what is the superclass of teacher class. Okay, to know the superclass of the teacher class, I can use this basis attribute. So when I use this basis attribute, it is printing me that the base attribute of the base class of the teacher class is person. Okay, so it is showing you that. Okay, it will give the details of the superclass. So the superclass of teacher is person. So I'll be getting that detail. Okay, right. Because in the right to extract the basis of a class, I got object as the answer. If you remember it, do you remember it, girls? When I try to print the basis of a particular class in the previous unit, I got the answer as object. Then I told you that for every class, the superclass is object class. Do you
Yes,
remember?
ma'am.
Yes.
Yes,
Okay.
ma'am.
There, because we do not have inheritance, the superclass for every class, the superclass is object. So we are getting the object name over here in the output. But here, since teachers, the superclass is person, so I can specifically tell that over here. Okay, so that's why I have picked that attribute here to show you the answer. Okay, now we are moving into very, very important concepts, which is method overloading. Now, this is an interview question also, like whether Python supports method overloading or not. Okay, after listening to this class, you will understand whether Python supports method overloading or not. Now, what is method overloading? The concept of method overloading means that the name of the methods will be same. Okay, so the name of the methods will be same. This is irrespective of the classes concept. Then I'll apply this into the classes and I'll show you the answer. Okay, now I'm showing you a program wherein there is no class. This is a main program, and I'll just uh, uh, talking about method overloading in terms of functions. Okay, so herein I'm having two functions. The name of the functions are same. Okay, I have explained that I'm passing into these two product functions are different. Into this product, I'm passing two arguments. Into this product, I'm passing three arguments. Okay, so this concept is called as method overloading. Okay, method overloading is a concept, so it depends from programming language to programming language. Since I know Java also and C also and Python, I'm able to give you these comparisons because this is very, very important concept for any student. You need to have comparison between the programming languages, and also these are very important for your final interviews. Okay, because they'll ask you that method overloading is supported in Java. Okay, multiple inheritance is supported in Python, but it is not supported in Java. So certain things are there, like which differentiate a programming language to a programming language. So which you need to keep in mind. So here I'm talking about a function which is having the same name. So what's the definition of the overloading concept? The definition of overloading is that I can have two functions with the same name with different signature. Signature means that the number of arguments and their type. Okay, fine. So here I'm having two arguments and here I'm having three arguments. Now when I call a method, okay, so I'm calling the method, I'm calling the function with the two arguments. Now generally what happens is based on the count of the attributes, the concerned method will be called. Okay, so in programming languages, even in C++, this is possible. Okay, but what happens in Python is, you can see that I'm getting an error. Okay, so you can see that I'm getting an error. Okay, I already told you this concept when I discussed the functions, that whenever you're having two functions with the same name, the latest version of the functions only will be considered. Did you recall this point one? Did you remember this point?
Yes, ma'am.
Yes,
When
ma'am.
the version is product ABC, so this method only will be considered. This method will not be considered, even if it is not syntax. Calling the method with the three attributes, even if this method is there, there won't be any problem. That's what I'm telling you. Syntactically, even if it is there inside your program or not there, it is not a problem. But you have to call only the latest version. You have to call the latest version which is having three attributes. Then only this will work. Meaning that method overloading is not supported by Python. Python do not support it. Okay, only the latest version will be considered. But in the other languages like in Java and C++ and all that, method overloading is possible. Okay, you can call this method, whatever method you want, you can call it. Okay, and this is what method overloading is, a concept of compile time polymorphism, where the binding happens during compile time, because it knows like it's having two attributes, three attributes, it knows it. Okay, so this is the concept of method overloading. But see, in the next case, even if this is there inside your program, it is not syntactically wrong, but I am just calling it with the three attributes. When I called it on the three attributes, because it's the latest version, it executes and it's just written in the output for me. Okay, so this is method overloading, but there is no way to call this product. Okay, with two arguments, there is no way. So that's the reason Python do not support method overloading. Now coming to the classes concepts, because we'll see this method overloading in the classes concept of Java. Okay, so I'm just applying this method overloading for the classes concept. Say for example, I'm having this is class A and I'm having two methods in class A. Very important concepts, and there will be no interview. Okay, so any interview that you take, it is TCS, Ninja, or it is Infosys, or it is open text, or it can be Accenture or Capgemini, or any kind of interviews. If you take like every interview, the first question they'll ask you is about polymorphism, object oriented programming principles, right? Polymorphism is one of the object oriented principles, and there are two kinds of polymorphisms. One is method overloading and the other is method overriding. I can simply skip this concept in your classes. You can see that. So I have two methods with the same name. So I have product and product. The names of the methods are same, but the signature is different. So here you can see that I have two attributes passed, and here you can see that there are three arguments passed. Okay, but when I'm trying to call the product with two arguments, I'm getting an error. Okay, and when I call it on, so how can I achieve method overloading? Okay, so is there any way to achieve method overloading in Python? Yes, you can achieve it, but with a different strategy. So what I'm doing here is, I know that the third argument do not work. So I want to call the same product of different number of arguments. Okay, so I can write only single name, single product, but wherein I'm saying C is equal to none. So herein I have used the concept of default arguments. So what happens is, if I'm not passing the third argument, the default argument is taken, and inside it I have written a logic in such a way that it does the product. Okay, so if C is equal to null, I am doing the product of A into B. And if I'm passing C, automatically it takes in the argument that I passed, and this will be this product. In the else part, it will do the product and print for me. Okay, wherein I'm achieving the same concept of a method overloading, but in a different way. Wherein herein I'm not having two methods with the same name, but that's the definition of method overloading, that you need to have two methods with the same name. but with different kinds of arguments. That is method overloading. That's a definition of method overloading. If anybody asks you in the interview what is a method overloading definition, you have to say that. Two methods having the same name with different method signature is called as method overloading. Okay, and but here the same concept of method overloading only, but we are achieving it in a different way because Python do not support it. Okay, so is method overloading clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
so next we'll in the afternoon class, right? So